Hello everyone and welcome to the next Earth Science review video. This is Unit 3, the Sun's Path. Now I'm going to preface this video right now by saying I recommend not relying solely on this video to learn this material. This is one of the more in-depth topics that there are in astronomy, and there's a lot to cover, and this is just going to be a very vague general overview of the concepts. Now I'm going to go into a little depth, but generally this is not going to be a replacement for studying your notes and, asking the teacher for help and making sure you understand this stuff, because it's not something that you could just pick up right off a little video. So this should give you a little extra boost in understanding, and I do have practice questions that I'm going to go over. So this right here is called a celestial sphere. And right now we're just going to set a couple of rules. So this right here would be considered the north over on the bottom right here. And so that means this is south, and that means this is east, and this is west. Now I'm not going to be explaining how a celestial sphere works or what it is, because that would take way too long. So we're going to plot the sun's path for New York, which is going to be 42 degrees north. So there's three pieces of information you got to know. You got to know the direction that it rises, direction that the sun sets, and then the altitude of the sun at solar noon. So if you get those three pieces of information, you can draw the path of the sun for that day at any location that you want on the whole planet. So for 42 degrees north, to find the altitude of the sun on the equinox, which is March and September, you're going to do 90 degrees minus 42 degrees north, which is the location. And that's going to give you 48 degrees altitude. So that means at solar noon on the equinox, the sun gets to 48 degrees. Now, on the equinox, the sun rises directly east and directly west. So all we got to do is plot one dot at the east, one dot at the west, and since we're in the northern hemisphere, the sun at solar noon at 48 degrees is going to be in the southern part of the sky. It's always the opposite. So right about here. And we're going to say it rises up to solar noon, and then it sets in the west. So this would be the sun's path in New York on March 21st and September 23rd. So now if we want to figure out what it's going to be in June or in the summer, we just go to that equinox number on the top and we add 23.5 degrees, which is the Earth's tilt. So every season, the sun actually changes in altitude by 23.5 degrees. So going from spring to summer, this is going to equal 71.5 degrees. And to figure out what direction it rises and sets, there's a little cool trick. So in June, it rises in the northeast. You see it in June? So it's going to set in the northwest in June. Northeast to northwest. You're going to have to just end up remembering this stuff, by the way. So northeast is here, put a dot. Northwest is here, put a dot. And then we got to put a dot at 71.5 degrees in the southern sky, and we're going to connect that. Don't mind my sloppy lines. It's hard to draw on this thing. And this is the June 21st path. And now for December, you take 48 degrees and you subtract the tilt. So that's going to end up being 24.5 degrees. And in December, you could see D-E-S-E. If you spell December wrong like that, you can remember that the sun rises in the southeast in December, which means it sets in the southwest. So we put a dot at southeast, put a dot at southwest, and then put a dot at 24.5 in the southern hemisphere. And there is the last path in New York, and this is 1221. So now that we have the three paths drawn, there's a couple of facts you got to know about the paths. The first fact is they are 23.5 degrees apart, each of them, and they're about 3 months apart. So every 3 months, the sun at solar noon will be 23.5 degrees higher in the sky until it gets to summer, and then it'll go 23.5 degrees lower, and then 23.5 degrees lower again for the winter, and then it just goes back and forth and back and forth and back and forth. All right? The second thing you got to know about the path is general times on the path. So I'm going to actually change to a green color here. So if I were to say green dot here is A, green dot here is B, green dot up at solar noon up here is C, and then this is D, and this is E. If I were to ask you what clock time it would be, approximately, we normally say sunrise, which is located at A, would be about 6 o'clock in the morning. At B would be 3 hours later, so this is 9 o'clock in the morning. At solar noon, C, we estimate to be about 12 p.m. At D, we're starting to set, so this is going to be about 3 p.m., and then sun sets generally at 6 p.m. So obviously this is not right for the summer, but this is just general overview of times on the sun's path. All right? So this is an actual picture of New York's sun's path at 42 degrees north. Now, if you were to see this for 42 degrees south, it would be a mirror image, so you would see the sun at solar noon all in the northern hemisphere. Okay? So the next 6 pictures that I'm going to show are pictures that you're going to have to be very familiar with just immediately recognizing. So whether you might have to make some index cards or watch this video a couple times to generally figure out which path is which. So I tried to come up with as many of decent pictures as I could for this video. So this is what New York generally looks like. This is the equator. So I'm not going to be making each path separately. You're just going to have to pretty much remember what we did in class and then add this as a little study guide. So the equator looks like 3 parallel arches. This is the Tropic of Cancer. The reason it's the Tropic of Cancer, which is 23.5 degrees north, is because all the suns at solar noon here are in the southern sky. And on its longest path, which would be June 21st, you have a 90-degree angle with the person standing here. So it would be directly above their head. So that's how you know that this is the Tropic of Cancer. So this is the Tropic of Capricorn, 23.5 degrees south. This is actually the mirror image of what you're going to see at the Tropic of Cancer. So here's the summer path. I know, I'm sorry about the bottom of the sphere. There's really no good images of this. Here is the equinox, and here is the smaller December path. Or this would actually be June. So generally, what you should look for is there's your 3 suns, solar noon. They're in the north, so you know you're in the southern hemisphere. And the biggest one up here is at 90 degrees. So the only place where you have these 3 happening in the northern hemisphere with one at 90 is going to be the Tropic of Capricorn. North Pole looks like this. The dead giveaway for the North Pole is that all directions are going to be south. Because if you're at the North Pole, no matter what, you're going to walk south if you were to go in any direction. And the sun is going to be just revolving in a circle because it's going to be 24 hours of daylight in this image. This is the South Pole. It's the complete opposite. So you would see the sun going in a circle just like the North Pole, except you would see all directions as north. Okay, so let's do some practice questions and see how you do. So again, I recommend pausing the video, seeing what you could do, and you'll see how you do when I go over it. So here we go. The diagram below represents the path of the sun at 65 degrees north on March 21st. The sun's position shown in the diagram was observed closest to which time? So remember, sunrise is 6 a.m. Right here is 9 a.m. Right here is about 12 p.m. Right here is about 3 p.m. and right here is about 6 p.m. So there's your answer. It would be C, 3 p.m. Nice and easy. Next question is a double question, 2 and 3. So we got a model of the sky for an observer in New York. This is big important information. So 42 degrees north. The altitude of Polaris is also indicated. That's interesting. So on which date could this observer of the sun's apparent path have been made? So a key factor to notice is that the sun's rising directly east and directly west, which means this has to be an equinox, which means it's either fall or spring. So it looks like December's out, July's out, and the only one is there is March 21st. October 21st is not a thing. And then it says, where is this observer most likely located? Well, we could figure out the location based on the altitude of Polaris. Polaris is at 40, it looks like 41.5 degrees. So if you go to this map and you look for about 41.5 or 42 degrees, Slide Mountain looks really close. You could check the other places, Oswego, Messina, and Mount Marcy. So Oswego, Mount Marcy's up here. There's no way that's right. Messina's all the way up here. No way. And Oswego's up here. So they're way too high up. So Slide Mountain looks like it's going to be your closest answer. C. All right, we got a shadow question. So generally for shadows, all you got to know is the higher the sun equals a shorter shadow. So times that you would have a higher sun would be the summer or when the sun is at solar noon for the day. That would be your highest shadow for the day. Summer would be your highest shadow for the year. So your lowest shadow, your shortest shadow is going to be in the summer. Your longer shadow will be in the winter or when the sun is rising or setting. So it says, which shadow was cast by the same telephone pole on June 21st? Well, it's not going to be the opposite direction because the sun is always going to be in the same sky at solar noon. It's going to be in the southern sky if you're in New York State, which we are. So it's going to be in the same direction. But in June 21st, the sun's higher in the sky, so you're going to have a shorter shadow. So B is the best answer. This answer, A, would be winter. This would be December shadow because it's going to be in the same direction, but it would be longer length. And D is the same length, which is not going to be true because the sun's going to change position. Which model best represents the apparent path of the sun observed at various times during the year at the equator? So this shows that it's always the same path, which is not true. We did the equator's path, and there's 3 different paths, so this is out. This one here shows that the sun is always rising east and west the whole year. This never happens at any location on the planet, so that's out. This location here shows the sun always getting up to 90 degrees on every day of the first day of the season. This is out. That never happens on anywhere on the planet. And here's your correct image of the equator, which we know and love. In which direction will the sunrise occur on June 21st? June, J-U capital N capital E, northeast. North of due east is just a fancy way of saying northeast. South of due east would be December. And then north of due west and south of due west, these are sunsets. So this would be sunset in June, and this would be sunset in December. Which diagram represents the path seen by an observer at 43.5 degrees latitude north on December 21st? This is very close to New York. So on December 21st, the sun is going to rise in the southeast. So find the one that rises in the southeast. This rises in the northeast, so this is out. This rises directly east, so this is out. This rises directly east, this is out. This rises southeast, yay! And it's low in the sky, which means you're going to get a shorter day, and it's cold, because low angle of insolation. All right, which table shows the dates on the apparent paths that are observed? So C shows rises southeast, sets southwest. This is December. It's also the shortest path. That makes sense. Then we got the median path rising directly east and setting directly west. That's March and September. And then we got our long path and our highest path. That's your summer or June. So there we go. So June is A, which this is out. Oh, there's only one with June as A. Yay, D. What is the time interval from the sun's apparent path A to the sun's apparent path C? Well, we established this earlier. We said between every season, you move 23.5 degrees, the sun is going to change. And that's going to take about 3 months per seasonal change. So there's 3 months here. So then to get to C would be another 3 months. So this would be a total of 6 months. It's half a year to go from this, which would be the summer, to this, which would be the winter. Think about it. June to December is 6 months. All right, so there's your little overview on the sun's path. I hope you thought it was helpful, and good luck. All right, see you on the next one.